Section 3 deals with radicals and rational exponents. Radicals, as you remember, are expressions that use this symbol, the radical symbol. For example, square root of, say, 16, or the square root of x to the third power, or even some other roots like the cube root of, say, 27, fourth root of 54, and so on. So those are radicals. Rational expressions are similar to radicals. In fact, expressions of radicals can be written with rational exponents. But an example of that would be, say, 1/4 to the 1/2 power, or more simply, let's say we had 9 to the 1/2 power, 16 to the 2/3 power, things like that. Rational exponents are where we have expressions where the exponents are rational numbers. I want to start with some problems in checkpoint 1, and as a reminder, as I suggested back in section 1, when we do these checkpoints, what I recommend that you turn the video off, work out the problem, and then come back, turn the video on, and check to make sure that we agree on the solution. Okay, the first one, hopefully it's quite familiar, square root of 81. The square root, that means the square root of a number is the number that you would have to square to get the number inside. The number we squared to get 81 would be 9. So this would be equal to 9, simply 9. And it's not equal to -9. Don't confuse this with a method that we sometimes use to solve equations. If you have, for example, x squared is equal to 81, one method that we would use at times is to take the square root of both sides, and then we get over here as x, but in this case x would be equal to plus or minus 9. That's different than simply taking the square root. The square root of a number is always a positive number. Don't confuse that with a method we use to solve equations. The only square root of 81 is a positive 9. Okay, the next expression, it has a radical sign over the 9, so the square root of 9, and it has an opposite sign in front. When you do this, you should focus on this part first, find the square root of 9, and then take the opposite of it, the square root of 9. 3 squared is equal to 9, so the square root of 9 is going to be 3, but then we have to carry along this minus sign, so that will simplify to -3. Next one involves the use of a fraction. No problem. What fraction would we square? What number would you square to get 1/25? Well, if you think about it, with this large number denominator, we have to square a smaller number, a larger number to get this smaller number. And 5 squared is 25. What we can square is 1/5. 1/5 times 1/5 is equal to 1/25. So that would be the square root. The square root of 1/25 would be simply 1/5, because that's the number you square to get 1/25. Same idea, except we're using fractions. Okay, the last two hopefully will clarify a common mistake with the use of the radical. Some people look at this and they invent a property that does not exist, and they say, oh, this is equal to the square root of 36 plus the square root of 64. But that is not a property that you can use. If they're multiplied, you can split it off like that, but if they're added, you cannot do that. You have to actually, in this case, I would add these two numbers first and then take the square root. 36 plus 64 is 100, so this would be equal to the square root of 100. And the square root of 100, you multiply 10 by itself to get 100, so the square root of 100 would be 10. So this expression would simplify to 10. Okay? And this is what they don't want, or I certainly don't want you to confuse this with. Square root of 36 plus 64 is not equal to this. That is not a property. In this case, this is a different expression. We have to take this square root, take that square root, and then add them. The square root of 36 would be 6. Square root of 64 is 8. Add them, and you get 14. And again, notice these are not equal, so you cannot take this and write it as square root of 6 plus 64. You can't split it off like that when you have an expression with a plus in it.